In this video, we are going to study wave optics. Okay, the topic we are going to study is polarization. The main topics in wave optics are interference, polarization, and diffraction. So this is our second topic, polarization. Okay, so let me tell you what is polarization. Polarization is nothing but the process of converting an unpolarized ray of light or unpolarized light wave into polarized light wave is called as polarization. Okay, polarization is just a phenomena, we can say it is a process. So keep watching the video till the end. I'll make you understand every topic. Okay, so first of all, what is polarization? I have already told you, the process of converting unpolarized light into polarized light, simply unpolarized into polarized, is called polarization. Okay, this is very simple. It can be asked in 1 mark questions also. Okay, so let's recall the what we have studied in waves. Okay, that you have this chapter named as wave or electromagnetics, electromagnetic waves. In that chapter, we have studied about the relation of electric field, magnetic field, and the direction of propagation of waves. Okay, suppose there is an electromagnetic wave, or as you all know that electric field, magnetic field, and third is propagation of light. These are always perpendicular, right? So the relation between these three is c. C is the speed of wave by which it is propagating. Okay, and E naught by B naught, it is the electric field intensity, electric field we can say, and it is the magnetic field. The ratio of electric field to the magnetic field is called as speed of wave or speed of propagation or velocity of propagation. There are various names. Okay, so this was the relation what we have studied in electromagnetic waves. Now let's study this process. What is polarization? Okay, what is polarization and what is unpolarization and what is polarization simply. Okay, इसमें होता क्या है कि there is a point, this is a source. Okay, इस source से light निकलती है. Light is emitting from this source in all the directions. All the directions. Suppose this is a point in all the three dimensional. Okay, the light is being emitted from this point source. But the wave, they should be polarized, as we have studied. The electric field should be in one direction, and the magnetic field, it should be in another direction. They both should be perpendicular. It is okay, it is always valid. But these electric field waves, they should be parallel to each other. Okay, if they are parallel, then this is the required wave. But in this case, the electric field vectors or electric field lines, they are not parallel to each other. Okay, they are like, suppose one of the light is like this, another is like this. They are randomly distributed. This is the phenomena in unpolarized light. In which, and what do you mean by unpolarized light? The light in which the electric field waves or the electric field particle or waves are not parallel to each other. They are just randomly distributed. They are randomly aligned to each other. There is not a constant difference between all these things. They are like randomly aligned. And in a polarized light, the electric field, or we can say magnetic field, these lines are parallel to each other. And this is the source. If we pass this thing, unpolarized light, if we do the polarization, then what we get is polarized light. This is our investment and this is the product, right? And this is polarization. If this wave undergoes this process, then we will get polarized light. The main phenomena is that this randomly aligned electric field and magnetic field lines, they will get aligned in a particular direction and they will all be parallel to each other. I hope you got the point. One more thing, the device which is used for this process is called as Polaroid, right? Polarization, the process polarization is done by Polaroid. And what is polarization? The process of converting unpolarized light into polarized light. That is polarization. Or with this example also we can understand what happens is, suppose x is the direction of propagation of light, and along this y direction there is one wave, along the z direction there is another electric field. These both represent electric field vectors or magnetic field vectors, right? Direction is in z direction and y direction. In both the direction electric field is spreading, or it is there, and x is the direction of propagation. But after polarization, because we have to convert into a polarized light, what happens that the waves in this z direction, they are removed, or they are sent, they are aligned in the y direction. Y direction is inside the board. This was what is polarization. Okay, this was the basic process. The application of polarization, let me tell you, are they using sunglasses. Sunglasses we use, as you know, in sunglasses, like they used to filter the ultraviolet rays, or there are many 3D cameras also, 3D sunglasses also, like many things are there, like which are used to filter. The main thing is to filter the unwanted part. Okay, like we use sunglasses now. What is the function of sunglasses? They provide safe waves. They protect our eyes from what? From harmful rays or ultraviolet rays, or the rays which are not required. The rays which are coming from sun, they are unpolarized, and that particular, or that stuff what is there inside the lens, that is Polaroid. Okay, after undergoing through the Polaroid, the what we get inside our eye, the lights which are getting inside our eyes, they are completely polarized light, and this is the required thing we want. This was what is happening in polarization. This was the practical thing which I showed you. And now we are going to study about the next phenomena, which is called as Brewster's Law and Malus Law. These are the processes which are used to do the polarization, to convert an unpolarized light into polarized light. So let's study. Now we will study the topics of converting the unpolarized light wave into polarized light wave. There are the two headings, two topics we can say. One is Brewster's Law and the second is Law of Malus. We are going to study about these topics now. So Brewster's Law, what it says? This is the diagram of Brewster's Law. This is the incoming or the incident ray, this is the reflected ray, and this is the refracted ray. Okay, or this is the unpolarized ray of wave of light. This is polarized and this is partially polarized. What is the statement? Let me tell you. The statement is, if the angle of incidence of the unpolarized wave, if the angle of incidence of the unpolarized wave is equal to tan inverse mu, then the light will get polarized. Okay, the only condition for polarization here is I should be equal to tan inverse mu. What is mu? Mu is the refractive index of second medium. This is air, refractive index will be 1. Right? So using this formula, we can find the incident angle in case of Brewster's Law. This is polarized ray of light and this is partially polarized. Partially polarized, what is partially polarized? The wave or the plane of the light waves in which the amplitude are different from this case. The amplitude of polarized light are different from unpolarized light. This is simple definition of partially polarized. The amplitude will not be same. This is partially polarized, the light will not be completely polarized. Okay, and in case of polarized, the light amplitudes, the electric field amplitudes, they will be parallel to each other. Right, they will be parallel to each other. This is simple thing in case of polarized light wave. This is the diagram this you will draw. And what is plane of polarization? What is this plane of polarization? Polarization. Plane of polarization is the first law of reflection, which says that the plane containing incident ray, reflected ray, and normal. This is the concept of plane of polarization. What is plane of polarization? The plane means 2D surface which contains the incident ray of light, the reflected ray of light, and the normal. Okay. All these are contained within plane of polarization. This was Brewster's law. Now let's come to law of Malus. Malus he did various experiments like to convert an unpolarized light ray wave into polarized. The final conclusion he got is this formula: I is I naught cos square theta. If we pass an unpolarized light wave through a Polaroid, let me recall, Polaroid is a device or a surface or any transparent medium which is used to convert the unpolarized into polarized, which is used to do the polarization. Simple. So this unpolarized light intensity is I naught and this polarized light wave intensity is I. Okay. So the relation between this output and input is output will be equal to input into cos square theta. And what is the theta? Theta is the angle between the axis of incident polarized light and the transmission axis of polarization. Means the difference between these two. Between axis, if this is like this and another axis is at an angle of 90 degree, okay, then theta will be 90 degree. Let's suppose these are the two polarides, okay. If they are like this, aligned like this, they are at an angle of 90 degree, then theta will be 90, cos 90 will be 0, and I naught into 0 will be 0. Then the resulting intensity we got is 0, okay. I naught and then output will be 0. Then what happened to the light? The light will be absorbed by the Polaroid, okay. But if we take the angle an integral multiple of pi, 1 pi, 2 pi, 3 pi, 4 pi, then what will happen? Then I will be equal to I naught. The input will be equal to output. Nothing will get absorbed, and the complete ray of light, like completely intensity, will be reflected in the output. There will be no change. Okay, this is the condition for law of Malus, or this is the formula we can say which is used to find the polarized light wave intensity. I is equal to I naught cos square theta, and theta is the angle between incident polarized light and the transmission axis of polarized side. So I hope you get these 2 points, these 2 definitions, these 2 laws, Brewster's law and Malus law. So if you like my video, my contents, then kindly press the like button and subscribe to my channel. Thank you.